Welcome to episode 10 of the PM Blend. I'm Mark Powell. This is Joe Finksler to my left.
Hi there, Mark.
Joe, nice shirt.
Thank you. I like the pants. They're
Nice.
good. They're good. They look good on you.
I know they do. I know they do. Matter of fact, you know how I know they do? Is because Tom moved from the couch to right
It's the right good to get closer.
Yeah.
Oh,
So I do know they look good on you.
Because they're going Halloween.
oh,
One.
we're not there yet.
Today in episode 10, we're not going to just talk about my pants. We're going to talk about machinability of PM parts today. And you're going to notice a couple guests that we've had before. Tom Finksler here to my right and Rob Powell on the far side of the couch, who joined us in episode 9. But we're also joined today by Dom Bivac. Dom, welcome.
Thank you.
Since this is your first opportunity to jump in the PM Blend, you are the lucky owner now of a PM Blend tumbler.
Oh, thank you.
There you go. Thanks for participating today and being part of our program.
Absolutely.
We appreciate that.
You don't get one every time you come.
Oh, no,
This is a one and done, Dom. So
no different colors or anything. Mark and I are still
No, it's-
same one for.
But no, welcome today. And if you've had a chance to watch our other episodes and you're back today, thank you. And, as far as future episodes go, if there's anything you do want to hear about, please let us know. We're happy to tailor these to whatever your questions or needs are. So, but again, today I mentioned we're going to talk about machinability of PM parts. And why don't we just jump into it, Joe?
Sounds good.
Okay. Dom, we're going to start off, put you on the hot seat here. Okay?
All right.
Just talk about what machinability is.
All right, so machinability is basically how easily different materials can be machined. There's some factors that play into that. Different materials, whether it's has like a iron nickel or an iron copper, the hardness, and then in powdered metal you have porosity, which definitely affects how well stuff can be machined.
Okay. All right. And then, so, we talk about powdered metal and always trying to, mold parts near net shape. Mm-hmm. But why is machining still relevant then with PM parts?
So there's a lot of detail, like face details and details on parts, and that cannot be molded in. So they'll get near net shape and molding, and then we will OD grooves or threads, stuff that just can't be molded in. We have to put in as a secondary operation.
You can't readily eject.
Yes,
is what we're trying to do. And occasionally he's doing some things that are just a slightly tighter tolerances, then we can hold that out of the mold process as well. You'll clean that up and tune that in.
Okay. Yeah. Yeah, that kind of leads into the next question, Joe. What kind of features or tolerances typically require machining in conventional PM parts?
Well, when you're molding a part, one of the areas for us that is a variable for us is the thickness, or what we quite often call the length of our parts. Mm-hmm. That's a variable in our stroke of our press. So there are occasions that a customer may want that qualified tighter than we can do. And there are also the areas that, as Dom's just alluded to, side holes, tapped holes, things like that we can't form and eject. And so those areas will also then get machined or tapped or turned or whatever the case be, lapped.
Yep.
Honed,
ground.
So yeah, there's a whole series of things. So an example of that would be if a customer's trying to press a bearing into one of our parts. Quite often our standard tolerance doesn't give them the equivalent pressing force that they want. So Dom will come in and do a cleanup of that to hold that to a tighter tolerance into the tenths. Yep. Usually about 3/10 or 4/10 neighborhood.
Yep.
Is what he'll run in that case. And then the customer has an easy and a very consistent time pressing that bearing into the component.
Okay.
Okay.
Now, machinability here has become, kind of at the forefront because it's been Joe, a couple of years. We had a full machine shop here, which is kind of unique to powder metal companies like ourselves. But for the audience out there to find other resources, like where would they go to find some of those resources, Joe, to kind of learn more about what you just spoke about?
Well, obviously they can come to us and we'll talk with them about that.
Sure.
And that's a natural place because we have a lot of conference calls with customers and Teams meetings with customers that we discuss those areas. But if a customer is also looking for something outside, the MPIF, the Metal Powders Industry Federation, they have an online course that you can take. And it basically talks about 15 different talks that various individuals that are involved in the industry have provided the MPIF to talk through some of the machinability characteristics of powdered metal and why it's more challenging sometimes than machining wrought. And it gives reasons and methods to get around some of those machinability issues.
Okay. Don, we did kind of touch on some of these different secondary processes or machining processes, but do you want to just kind of walk through some of the most common machining processes we have?
Yeah. So depending on like tolerances, we could OD grind, double disc grind, all threads we machine in, cross holes that can't be molded in, like different face details, OD grooves, ID grooves, and then turning different features on that can't be molded or have tight tolerances.
We have centerless grinding here as well, right?
Correct. Yep.
Okay. So, Rob, Tom, I'll just kind of throw this out there. As far as when we're looking at, machining certain materials, I know we've had many discussions with customers that this material doesn't machine as well as this material. You want to talk about, I'm not saying specific materials, but what maybe we can do to a material to make it more machining friendly.
So prior to my engineering experience, I actually have some machining experience. So I can kind of tie some of the machining operations in with the materials. As far as how the lab and our materials department can help understanding the microstructures is one thing, and the materials and how they're processed also factors in whether it's a center hardened material or not center hardened, heat treated, not heat treated. When that machining operation occurs within the production of the part can factor into what Dom needs to know when he's establishing his machining parameters.
Okay.
And we can also then, depending again, what has happened to the part through the process, you can secondarily add resin to help some of the machining issues that might run into. And as Rob indicated, our raw material may have some machining additives to help in that process as well.
Don, what considerations go into choosing the right cutting tools or conditions for machining PM parts?
I'd say the biggest one is what type of material we are machining. That's going to dictate whether we use carbide or CBN. We don't use much high speed steel tools other than our taps. But basically, and then like whatever geometry we're cutting and, whether we use coolant or we don't use coolant, it's all pretty much all ties back into what the material is and what operation we're actually doing.
Okay. Joe, I see we have some sample parts out here.
Right.
You, Dom, anyone in the group kind of want to talk about, the story behind these and where machining played a big part in these parts?
Well, I'll start it off, and I'm sure he'll jump in. There are examples of components that go into a heavy-duty truck application, and it was one of those parts that was a conversion for us. The customer at that time had been machining these things from stock, from bar, or I think one of them actually was a cast material, but they were throwing so much away that it didn't make any sense. So they approached us and allowed us to make some minor adjustments to it, and very minor adjustments to it, and it allowed us to form a blank for them. And in the case of the part on your side, over by Tom, that part starts out as that thickness of that middle section. And then Dom does a lot of machining out to that because we couldn't release couldn't displace all the material in the finished version. And then on the other side, there are just features, as Dom's alluded to, we can't make. And Dom, if you want to jump in and kind of describe what you're doing to them.
Yep. So on the part closest to me with the teeth on it, we actually turn that top hub on. And that's because the molding tools would be too thin, correct?
Yes.
So we have to machine that on. And then the ID of that part has a very tight tolerance, something that can't be held throughout the molding and sintering process. So we touch that up. And then there's drilled and tapped holes that we put in, and there's also an OD groove. And then on the other part, something I forgot to mention earlier. So another thing that we take into consideration is surface finish. So I know that part has a very low surface finish requirement. So that's something that we have to do because it can't be held throughout the process.
And he just alluded to the fact that the walls would be too thin. And what he's referring to is the teeth on the outside are formed the whole way up because we wouldn't have enough wall thickness to form those teeth in our mold cycle. So we're forming those the whole way up, and he's just machining that thin step down, basically taking down to almost to just below the valley of the teeth.
Correct. Yep.
So by forming a blank for this customer, machining it to its final shape, we were able to give them the strength they needed, and also a cost savings while doing so. Is that right?
Right. And the consistency that they were looking for.
And the consistency. Yep. Okay. Are there, Dom, any emerging trends or innovations in machining for them parts that you can talk about?
So working with a bunch of different tooling vendors, a lot of them are going to different grades of tools, different styles, which definitely helps with our tool life. We can send them prints and give them some information. They can give us what's the newest and greatest tool to help with our tool life on that.
Okay. And I know, Dom, from having parts that, obviously have gone through the shop back there, you and the team in our tooling department spent a lot of time designing and manufacturing fixturing, right?
Yes. Yep.
I mean, I don't know how much you can elaborate on that, but I know that's a big part of it.
Yes. So, I mean, again, it all depends on, what features we're doing, what machine it's running in, but there's definitely a lot of thought that goes into designing the fixtures and getting it made. And then, the different geometries can make that challenging sometimes to get exactly what we need.
How many of those fixturings, Dom, do we do in-house? Like if you were to say, all right, Mark, we make 90%. I know you design most of them in-house.
Yep.
But like as far as producing those fixtures, like how much of that goes out? How much of it stays?
I'd say currently we do probably 80% in-house.
Okay. Yep. All right. And then lastly, I'll just ask this the entire group, how is Atlas staying ahead in optimizing machinability for future applications?
I think we try to stay current on the raw materials and such, at least from a metallurgical side, will help us through the machining process is one way. So, I think also that we keep our ear to the ground and we go out there and network with suppliers and try to keep current with what's going out there through the industry conferences and committees and those types of things as well.
Other places, we listen to the customers as well.
Yeah.
We're talking about a lot of the machining that we do inside, but some of our customers also do machining. And so you pay attention to what the customers are running into. And that's a regular thing for us is to, and from the sales side, that our objective is to be passed through to that customer, that they feel comfortable talking with us if they're running into a problem. So that's a common thing for us to also get involved in.
And I know from sitting in our quoting meetings, Joe, I like the fact that when we look at parts, especially challenging geometries, we're looking at those and trying to be creative and saying, all right, can can Dom machine this? And we spend a lot of time talking about, how do we get it as close to net shape as we can through the molding process? But then what can Dom do to clean this part up to get it to that desired final shape that the customer wants and needs?
Yeah, we what you'll find is, and you do find is, we do our best to just not no quote something. We're trying to find ways, because we're looking for those conversions.
Right.
I mean, we're not just looking for what's out there in the current process. We're trying to help a customer make it more effective and make it more competitive in that case. So we're keeping an open mind to go, what can we do for the customer?
Right.
Sometimes we sit in the room and we hash it out, and the group of us will sit there and look at one another and go, this probably isn't going to be a hit for the customer. Mm-hmm. But you still go through that effort to do it. And occasionally you find out it costs the customer more than we had even anticipated. So it might be a little more work for Dom to machine, but if it's helping the customer, that's what really matters.
Right. I always like how you say in our PM 101s that, powder metal it's not a fix-all or a process for every part.
Correct.
But it's something to have in your holster.
Right.
And I think that's how you usually say it.
It's just another tool in the bag.
Yeah. Yep. All right. Anything else, guys? Well, listen, I want to thank you for watching episode 10 on Machinability. Thank you again for joining. And as I mentioned in the start, if there's another topic you would like us to cover, please let us know. And in the meantime, continue to follow our socials.